Okay.
Okay. All right, so we're here with Jose one more time. He's got a Math 221 question. This is in section 1.4, and we're going to do number 15. We want to examine a few features of this function, 1 over x, including the derivative. And we're going to have to figure out the derivative from the definition. So, Jose, first of all, what does f of x equals 1 over x look like? What does that graph look like?
It's going to have an asymptote somewhere.
Yeah.
And
so
it's going to be two separate.
Yeah, because it's undefined when x equals 0, so you know you got a problem there. So the domain is all x's except 0, and that's what this guy looks like. It's an example of a hyperbola. And it does go through the point 1, 1. And so we're supposed to draw the tangent lines at -2, 0, and 1. When x equals 0, there's nothing you can do, because the domain is everything except for 0. So we don't even have to do this problem. We just got to draw tangent lines at 1. So the tangent line is a line that touches the graph just in one spot. So that would be the tangent line right there. So I'm just going to dash it. And then at -2, where would that tangent line be?
It'd be the same, pretty much the same as the other one. Just,
yeah, -2 here. So if you had to estimate the slope, what would you estimate the slope is right here?
probably 1 over 1. Or
Yeah, it's going down.
Oh,
so you go down 1 and over 1.
Okay.
So what do you think the slope is?
-1.
Maybe -1. How about over here? Again, you're going down. So what do you think the slope is here?
-1 also? Or
Maybe, well, -1 would be like 45 degrees. Is it less than 45 degrees?
yes.
Yeah, so maybe it's like -0.5 or something.
Okay.
Okay, so now we're going to figure out f prime of x, the slope anywhere from the definition. So we've got to find the limit as h goes to 0 of that difference quotient. What's the difference quotient part? That's the f of x plus h minus f of x over h. So this is called the difference quotient. And this is a messy one. Okay, if f of x is 1 over x, what's f of x plus h?
1 over x plus h.
That's right. And f of x is 1 over x, we've got to divide by h. And this messes people up because it's a fraction inside of a bigger fraction. So pretty much until you cancel out an h on top and an h on bottom, you got to keep doing a bunch of algebra. So what's the common denominator of that mess on top?
On top it's 1. Or
What should we multiply top and bottom by here, and top and bottom by here, to get a common denominator? So if you have two fractions like a half minus a third, what's the common denominator?
1/6.
It would be 6. And what would we multiply top and bottom by here? 3 over 3, right?
Oh, okay.
And what would we multiply top and bottom by here?
3 over 3. Or 2 over 2.
2 over 2. So what should we multiply top and bottom by here?
X.
X over x.
Yeah, x over x.
And how about over here?
X plus h over x plus h.
Yeah, and I hope this is going to be visible on the video. So if we do that, then what is the common denominator? Here the common denominator was 6. What's the common denominator going to be here?
X squared plus hx.
Yeah, and you could leave it that way, or you could just have it, keep it that way.
Okay.
X times x plus h. And then what's the numerator going to be? Well, here we got that red x, and then we got minus the red x plus h. And all that messes over h. So does anything start canceling out here?
You go ahead and cancel the
An x minus an x, so what at least cancels there?
-x and x.
Yeah, so that'll go away. And what's left? So it looks like we got a negative h left over. Does that look right to you?
Yes.
And then we've got get my markers all mixed up here. And then we got an x plus h, and then we got this h down here. Now maybe it'll help for me to write this h as h over 1. How do you take a fraction over a fraction?
Multiply by the reciprocal.
Yeah. So why don't we do that? So we have the limit as h goes to 0. Negative h over x times x plus h times a 1 over h. Whatever. I'm trying to mix up my colors a little bit too much. Okay, so basically this h down here ends up pulling into the denominator. So another way to have done that is if you have a over b divided by c, that's the same as a over bc. The c just comes right up into the denominator. So this h just pulled up here. But I did it this other way because that might be more familiar to you. Fraction over fraction multiplied by the reciprocal. Now, over here, does anything cancel out?
Negative h and h are going to cancel out.
Boom. Yeah. And this is sort of how you know that you've gone far enough. You've not gone far enough in almost all these problems until an h cancels on top and bottom. So now we've got a negative 1 over x times x plus h. You know what this limit is. Can you just cheat and plug in 0 down?
Yes.
And what do you get when you do that?
It doesn't exist.
No, you're plugging, not x is 0, h is 0. Right? You're taking the limit as h is 0.
Yeah.
So if you cheat and plug in h is 0, what do we get?
X squared.
X squared. That is the derivative of our function. It's negative 1 over x squared. That's telling you the slope of the tangent line at any x. That formula is going to give it to you for this curve. So if we're at x equals 1, what's negative 1 over 1 squared?
Negative 1.
So m is f prime of 1, which is negative 1 over 1 squared. It's negative 1. That slope is negative 1. We guessed it, but it's exactly negative 1. How about over here? What's the slope going to be?
Negative 1/2.
It's negative 1 over,
Negative 1 over 4.
over negative 2 squared. So what's that equal to?
Negative 0.25.
Yeah, it's negative 1/4. So it's negative 0.25. Right? Because we used negative 1 over x squared. It's reminding us how we plug that in. So that slope's negative 1/4. We guessed it was negative 1/2. It's really negative 1/4. That means you go over 4 before you go down 1. And you know what? Maybe that's about right. Go over 4 down 1 before you hit that. And that's it.